Dude, sadly this weekend I have a Quizbowl tournament, so I don't have that much time to prep. So we're just gonna do the least prep thing that I actually gotta do. Bronze problem. Let's go. And we'll do it in Java because why not? We've done Python, we've done C++. Why not do Java? I'm not gonna lie to you. Like in doing Python, I just realized how much superior C++ is. But like, we gotta try out all the languages, okay? Hello everybody, I'm Kara, and today we are gonna be doing the 2020 January contest bronze problem. We already did race, like we already did a walkthrough on race, so I'm not, we'll just go through all of them for the sake of going through all of them, but we've already done race, so let's just do it and see what happens. Okay, word processor. Bessie the cow is working on an essay for her class since her handwriting is quite bad. She decides to type the essay using a word processor. Wow, very epic. The essay contains n words separated by spaces. Each word is between 1 and 15 characters long, inclusive, and consists of only uppercase and lowercase letters. Okay, has to be formatted. Okay. Using the font. If she types the word, it's okay. Alright. Alright. So she basically has. Wait, what? That's a big troll. Okay. So basically you have K characters for your thing, not counting spaces. Okay. Yeah, so this is pretty straightforward. You just read in the words, right? And then once you have all the words, you just go through, and then once you have all the words, you just go through each one, see if it goes over K. If it goes over K, you put on the next line. If it doesn't go over K, you don't put on the next line, you put on the current line. Okay. So let us do this. I've not coded in Java for a while, so please spare me. Don't roast me too hard. Hopefully I don't get roasted. What is this word? I hate Java though. Dude, what is this nonsense? Why do we need classes? Oh, it's so lame. Who needs classes? Okay, so we'll take our scanner. Go is equal to new scanner, new file. What? Well, word.in. Let's go. So now the first thing we need is we need to like have something to store our final essay, right? So we'll have string essay is equal to, it starts at nothing and it'll slowly add to it. Oh no, I gotta import Java util whatever nonsense. God dang it. Probably shrink this boy. Okay, and now we need our int n is equal to sku.next int, and we have our int k is equal to sku.next int, and then we just go for int I equals 0, I is less than n, I plus plus. Okay, and we should also have like our current, we also need, let's put this under, and we also need to keep track of how long our current line is, right? So right now our current line, like int car length is equal to 0, right? Our current line is no length. So now we have our string car, right? The next word to put in is good on next. And we basically check if car.length is greater than, or well, plus car length is greater than k. Is it at least? No more than. Okay, so yeah, if it's greater than k, then we want to move it to the next line. So all we gotta do is for essay, we do equals essay plus /n plus, or we can even do a plus equals to be cool. We are cool, okay, we are indeed cool. Why would you not use a plus equal? That's lame. And then plus car. And what do we set car length to? We want our car length. Our car length is now like the length of this new word we added, so we basically just set car length to car.length. But otherwise, if it's not longer, right, like if it fits in the line, we just put it on the line. And we do car length plus equals car.length. And we just do essay plus equals. Now, the one tricky thing, right, is like, do we put a space before? Okay, well, yeah, we can just start off our essay with sku.next, and then that fixes all of the edge cases. So now, all we gotta do is do space plus our actual word. Okay. And now, if we just do system.out.println at the end, our essay should be right. Theoretically. Essay! Hey, okay, let's try it. There's a 200% chance it doesn't work, but that is okay. We don't tell me the odds, okay? Is that a meme? I don't know how this works. I just know that it's a famous thing. I forgot where it's from. It's so sad. Come on, work, bruh. Hey Java. God dang it. There we go. Come on, dude. Why does Java gotta be like this? Python is just the best, okay? Okay. So now we gotta throw an IO exception, bruh. Oh, I think we gotta do skid on the next line here. So skip over that new line character, and then it should be fine. What? It needs to be less than n minus 1. Oh, created of 2, I equals 1. That would make more sense, okay. Finally, let's go. That was wrong, but okay, it's still wrong, but like, you know what I'm saying? It's still good. At least it's printing something. So now we gotta be kind of smart about this. Oh, that would make sense. Alright, so it starts off as sa.left. Okay. And now, if we try it, it better work. Hey, alright. Now the part that I hate about Java, other than like the fact that you had to do like 69 characters just to make a scanner, is that you had to make even more, like 420 characters just to like do the actual printing to a file. God dang it. Okay, so we're gonna do a buffered writer. I totally forgot how to do this. This is gonna be so sad. Okay, buffered writer, new file reader or something, right? File reader. Yeah. Okay, and then new file. All right. And then we do word.app. Oh my god, this is epic. Let's go. bw.write essay. And then bw.code. Alright. Now this better work. And it didn't work. Yes, let's go. What? Oh, that does new writer? Oh, file reader. Nice. File writer. There we go. Hey, we did it, boys. We know how to do Java. Okay, now we just gotta download this boy. Alright, moment of truth. Do we know how to do Java? We do not, but like, what will work? That's the question. Easy peasy lemon squeezy, that's how we do it. Okay, now we gotta move on to the next one. Alright, number 2, Photoshoot. Farmer John is lining up his end cows. He has end cows, that's crazy. Number 1 to N4, Photoshoot. FJ initially planned for the ice cow from the left to be cow numbered AI, okay. Hooray, permutations on a sheet of paper. Unfortunately, it was stolen by... Who the heck? I had not seen that one before, but Nahaj, apparently. Okay, I noticed it was drawn backwards. Okay, I'm not that dumb. Okay, I probably am, but you know what I'm saying? Luckily, it might still be possible for Farmer John to recover the permutation he originally wrote down before the sheet was stolen. Bessie recorded the okay, and based on, okay, you want to find the lexicographically minimum. Okay, so essentially you're just given your bees, right? Yeah, you're just given bees, and then you want to find the smallest permutation. So how could you possibly do this? Well, okay, so if we have the, okay, so it's AI plus, okay, let's open the Photoshop. Alrighty, so basically we have like A0 plus A1, right? Or I guess we could do 1 to N. A1 plus A2, A2 plus A3, so on and so forth. So if we subtract them, we basically get, well, okay, we have n unknowns and n minus 1 equations, which is annoying, but what could we find? So we get A3 minus A1, okay. Or could you find everything in terms of, like, relative to A1? Because then it's easy. So you can find A4 minus A2, which means you could find, well, you know what A3 plus, or A4 minus, no, what? Okay, so you know what A5 minus A3 is. Okay, well, you for sure could do all the odd numbers relative to 1, right? Because then you could get, like, A5 minus A3, and then add it to this, and then it works, and you could just go down, like, A7 plus A5, and then you eventually get down to A7 minus A1. So we know all the odd ones relative to A1, but could we find like A2 minus A1? Is that possible? Because if that's possible, then like we know all the odd even numbers. Wait, what? Why is it a bronze problem? This needs math. Math is annoying. Oh, wait. How big is n? 10 to the 3, so you can't do exponential, but what could you do? It's only 10 to the 3 though. That means you could do like n squared, I guess. I mean, how does n squared help? Well, okay, so if you have a1, then you know what a2 is, in which case you determine all of the other ones too, though. I mean, yeah, you could find all of them relative to a1, or in terms of a1. Yeah, so basically once a1 is fixed... Oh, hold up. How big... Oh, wait. Oh, that's so big brain, dude. Wait. Bruh. Hold up. So you can literally go from n is equal to 1 through 1000, right? And you can just test it out and see if it results in a permutation. And basically you want your A1 to be as small as possible for it to be lexicographically smallest, but once you decide A1, then everything else is uniquely determined. So basically you just go from 1 to 1000, and the first one that gives you a permutation is the right one, because it gives you a permutation and you know your A1 is the smallest that it could possibly be. Alright, let's do it. Let's go. Alright. I mean, there might be a smarter way to do it, but like, you know, bronze, okay? Just do it. Brute force. Whatever you want to do, just do it. Make your dreams come true. Alright, photo. And we'll drag this boy out a little bit. And now we do our epic stuff. So, scanner scope. Alright, so int n is equal to stood on next int. Alright, then we'll just do stood on next line for the sake of, actually we don't even need to do that. Yeah, okay, yeah, because it's all int, so it's easy. So let's just make an array, right? So, and, dude, Java arrays are so annoying to make too, though. Okay, so int, like, what do we call these boys? I don't know, b. is equal to new int n. Oh, I forgot, dude. Okay, the good thing about Java is that you can have variable length arrays, which makes me feel good, because then you don't have all this extra space. But that's a one good thing, okay? One redeeming quality. Is that even how you do it? Hold up. There we go. Is that? I don't even know. Okay, that should be fine. This is triggering me, is this right? Okay, we'll see after it compiles. Okay. Alright, so now we have all our BIs. Okay, it's n minus 1, so that should be better. Okay, and now we literally just loop through this for int I equals 0, I is less than or equal to n? How big? Oh, it should be. So the biggest it gets is equal to it. So we do is less than or equal to 5 or n, and then I plus plus. Hey, it doesn't work. Okay, that's not how you do it then, I suppose. Is it gonna say unexpected parentheses or something? Hey, loading, hooray. Huh? Is that right? Okay, that's how you do it. Okay, start from 1. Okay, so now we basically want to check if it's a permutation, right? And the best way to do it is just to keep an array of which ones you've already seen, like a visited array, right? And make sure that you hit all of them, right? Because if you're able to hit 1, 2, 3, 4, and 5 in n, like in 5 spaces, that means it must be some ordering of 1, 2, 3, 4, 5. So we're gonna do int like visited, okay. New int n, okay. Or we could just be bool. And basically what we're gonna do is like I is basically our first number, right? So if we want to get the second number, we just do 4 minus I. So let's do like int car equals I, and we'll do while or for int I equals 1, I is less than n, or j. Oh man, we gotta use a different variable. Okay. And basically we're just gonna set visited card is equal to true. Or why don't we just say we'll set visited card equal to true at the very end of each loop. So we'll do that. And then at the beginning, what we want to do is we want to find the next one, right? So basically the next one is just gonna be, well, we could do 0 to n minus 1 for ease of stuff. And we basically set car is equal to b j minus what? Car. Yeah. So now this is the next number, and we basically set it's visited to true, and at the very end you just want to check that all of the visited are true. So we could say bool valid is equal to true. Should it be default true? Yeah, because if any of them are false, then it's not valid. So if not visited car valid equals false. Okay, like technically the best way to do this, you know, we're just gonna be cool. It would be valid is equal to valid and could you do and n equal? Could you? I'm gonna try that. Valid and n equal visited j. Alright. Make it n plus 1. And then we'll do 1 less than. Oh god, you can't do it. That's so sad. Alright. Okay, can you? Oh, you can't. Oh, maybe you could. Bruh. Oh, you can't. This is so sad. Alright. That should be fine. So basically, if it ever becomes false, like, it's gonna be true and false, so valid is gonna become false, and then you'll always have a false plus a true. So if any of them are false, it's gonna make the whole thing false. And then we just, if valid, we just print out our permutation. So I guess we never actually store our permutation, so we probably should do that. Array list al is equal to new array list al dot add. And then if it's valid, we just want to print out all of the ints in it. Is there a fast way to do it? Is there a fast way to do it? Let's see. Print out array list space separated. Huh. That seems fun. String.join. Oh, you can just do string.join. Oh, nice. Should we try that? Let's try it. String.join and al, and we'll print that. And we'll return. Okay, and eventually it should work, so let's test that. How many compilation errors do you think we'll get this time? Hey, we got 1! Okay, so what's the problem? Question mark? Oh, string.join. What? Let's see. Okay, so we're getting the right permutation, so now we just need to make sure we figure out a way to get rid of the thingamajigs. Oh, wait, that's so big brain. Okay, well, I mean, print int of array list with space separated. Oh, that's too complicated. Come on, there's gotta be an easier way. Come on, dude, that's so stupid. Yeah, okay, whatever. We'll just do it for each loop. For int j in al, print, that's lame, j plus space. Or, well, yeah, we can do that. And then we'll just, at the very end, we'll do a print line just to be cool. Okay, say what now? Oh, maybe then our join thing works. integer. Alright. Can we try that? I think it might work. Well, let's just put it above just to be sure. Oh, what? Alright. Okay. Oh, well, we could just do this as a string, right? And then add it as a string. Okay. Dude, why am I trying so hard? Okay. We gotta have elegant code, okay? That's the only thing that matters. Epic. Did it print anything? Why didn't it print anything? Okay, well, I guess it's the compile time error. Let's go, that's beautiful. Okay, now all we gotta do is make our buffered writer. I love buffered writers. Alright, nice. Okay, so now let's just make sure it's making the file correctly, and then we can download it, and then we can submit it, and we could be epic. Let's go. No, what? What? Wait a minute. What does that even mean? God dang it. Wait, what? Did I put hardcode 5 anywhere or something? Oh, okay, yeah, because this could be bigger than n. Alright, yeah. So, we gotta make sure that our car is never bigger than n. If car is greater than n, yeah, greater than n, then we want to return fall, or break. What do we want to do? Break, yeah. Hey, there we go. That was don't talk too soon, I guess. Wait, what? Bruh. So I feel like it's probably like some out of bound there, right? So we're going from visited to n. Okay, so that's fine. We're checking visited cart. Oh, okay, it also could be less than 0, so we don't want it to be less than 0. That would make sense. Less than 1, actually, we don't want it to be. So if it's either of those two things, then it's dead. Alright. I like how it's like perfectly split between the stuff that worked and the stuff that doesn't work. Like that must be a coincidence, right? No way. This is so sad. Why did it take me 3 tries to do a bronze problem? God dang it. Don't worry, we did it though. We did it though. That's what matters. Okay, and you know, just for the sake of completeness, why don't we just do the last one in Java? Why not? I already did it, but you know, I'm pretty sure I did it in C, so might as well finish in Java. Okay, so Bessie is running a race of length k meters. Okay, she starts running at a speed of 0 meters per second. In any given second, she can either increase its speed. Okay, and for example, in the first second, she can either increase its speed to 1 meter. Okay, and her speed can never drop below 0. And she wants to finish after an integer amount of seconds. Okay, and she doesn't want to run too quickly at the finish line. So when she finishes, she wants to slow down. Okay, alright. So for each possible x, we want to print out a different thing. So I think the thing we realized last time, like I remember this, so I'm not going to pretend like I'm figuring it out again, but basically the idea is like, the best idea is to always, like keep increasing your speed as much as possible, and then decrease your speed as much as possible, just so you can barely reach your x, right? Like your, what is it? It's x to, yeah, x. You want to like go up straight and then go down straight and end up at x. Like if you stop increasing your speed at some point, there's always this extra area that you could have gotten like more like stuff. So the best way is always if you have like a sharp point at the top. So this is like x, right? Then what is this? Well, basically the idea is, right, like if you go backward in time, like every second you get to change it by 1, plus or minus 1, right? So essentially, if you go back like t seconds, right, this is going to be your speed x plus t, right? And then this is going to be total t. So how long is total t? K, what's k? Oh, so you don't know what your total t is. You only know what your area of this nonsense is. Well, okay, so basically the distance you go is like 1 plus 2 plus 3 plus 4, right? And then you want to go down again so that you end up at x. Okay, so why don't we just call the max like that you have is m, right? And basically your m, so this is going to be m plus m minus 1 all the way down to 1, right? You start at how fast? Oh, you start at 0. Wait, what? How does this work exactly? So in the first second she can, okay, so it happens immediately. Well, yeah, I mean, yeah, okay. And what do we want to print out? Minimum amount of time. Oh yeah, so basically it's going to be m plus like 1 times m over 2, right? That's just the formula for it. And then now I need to find this, like sum of this distances. So that's just going to be m plus x, right? Times m minus, like x minus m over 2. Like that's okay, so plus m plus x, right? And then the number of pairs, which is m minus x plus 1 over 2. And that will give you this thing. But we have 1 extra. Oh yeah, this should be m minus 1, because you basically start from here, and this should be m minus x. So m plus x minus 1, there. Okay, this seems nasty, dude. Okay, hold up. Let us do some algebra, shall we? So we basically get m squared plus m squared well, what does this give us? So then you get plus m squared plus mx minus m minus mx minus x squared plus x. Okay, so this cancels out, this cancels out, this cancels out, that cancels out, and we get like 3m squared. Holy moly, what? How do we get 3m squared? Huh? How? What? Did I just like, okay, I was just trolling, I think. Okay, so 2m squared minus x squared plus x. Okay, over 2. And basically, like, if you're ever gonna take off like somewhere, it's better instead of going like this, right? It's always better to like flatten at the top, cause like if you compare this to like that area, right? Like the amount you're cutting off is better if you just like go up as much as you can, stay at something, and then go down. Cause you have to like end exactly on t, cause you need an integer amount of time. Okay. And then we could basically add like some amount of m's in here. Plus m's k. Okay. So basically the idea is we are trying to make this as close to x as possible, and then we put in whatever's left with this. Well, okay, so right here, this gives us like the best possible time, right? So if we find m here, right, then we can find the best possible time. And that just boils down to like, wait, what does that just boil down to? Okay, hold up. Let us think a little bit more. So you go one, okay, and then at some point you're just gonna get like some m that finally gets you over the, or barely enough. If you went up one more m, you'd have to add in like one taller one and one go back down again, and that would be 2 over the top, right? Because that would give you m plus 1 plus m more time if you went up another one. So essentially your next thing would be 2m plus 1. So essentially we want to find an m that if you added 2m plus 1, it would go over your distance, which is k, okay? So then we know we're at most 2m plus 1 off from the k we want. So how could we add in stuff? So we know we can't go up one more, but we basically could add, we'll have to just add, we could add like one here. Whatever we do, we could either just add like one m here, we could add another m here, and then you get 2m, right? Or like, you could just add in things wherever they need to be, and it'll work, right? So basically, if the remainder is greater than 2, if it is greater than m, then you can't just add one slice, you'll have to add 2 slices, and so on and so forth. So yeah, we basically want to find the best m for this to work, and then add in time as necessary. Okay. Oh wait, so okay, so that makes sense, right? So essentially, if you have like your m is what? So m is at least x, right? So essentially it starts off like this, it goes all the way up to x. Huh, wait. Well, I guess we could just calculate it for different m's, right? So it'd be 2m squared minus x squared plus x over 2. Is that right? So let's say your m is 4, your x is 3, then you get 4 plus 3 plus 3 plus 2 plus 1 is 13. Okay, and if you plug it in here, do we get that? So we get 32 minus 9 plus 3. 32 minus 9 plus 3. Oh, it is. Hey, this is the right formula. Okay, right? So essentially we could just plug in m's until it works. Well, in other words, it's like m squared like minus some constant, because x is some constant. Or wait, this is just a square, and this has to be like greater, or like one less than m plus 1 squared minus, okay, this whole thing would have to be greater than k. Oh, so we basically just like move this constant to this side, take the square root, and then we get our m immediately, and then we just like calculate how many more bars we need to add. Oh, alright, yeah, that makes sense. Okay, let's do it. Yeah, so basically the idea is we could like just use math to find the m, right? We take the floor of the square root of like k plus x squared minus x over 2. We take the square root of that, we get, and floor of that, we get our m, right? And then based on that, if there's 2m left over, right, then we have to add 2 more bars. If there's only m left over, we only have to add 1 more bar, and then we basically get our answer. Alright, let us start reading stuff in. Alright, so now we basically just go through each x, and we'll basically just go int I equals 0, I less than n, I plus plus, and we basically say int x is equal to square.next int. And now we can literally just calculate our m is equal to like math.floor, math.square root of k plus x times x minus or over 2 minus x over 2. Alright, so now we got our m, and basically we want to see how much is going to be left over. So our current our current, like, okay, so our current length is going to be like m squared, the formula we came up with. So int car distance is equal to 2 times m plus x times x plus x minus this nonsense, and then divide by 2. And now our difference, or we only need the difference, so we do diff is k minus this. So if it is like, okay, so int t, right? Basically, let's figure out what our time is, right? So if you go to 4, there's 4 lines here, right? And then the number of lines after is just like 4 minus 3, which is 1. So essentially, we just do int t is equal to m plus m minus x. So 2 times m minus x, okay? And then we just do some casework, right? So if diff is greater than m, then we got to add in 2 more bars, right? And basically the way we would do that is we would do print sum.out.println t plus 2. Okay. Otherwise, if diff is greater than 0, then we have to print out t plus 1. And lastly, if none of those are satisfied, then we just print out t. Okay, let's try it. Oops, didn't throw an IO exception, god dang it. And didn't import like anything. Oops. Okay, we'll just cast it to an int, get roasted. Is it still gonna roast me? Hey, I think it worked. Nice. Alright, so now we just gotta make our epic buffered writer. Same thing. Okay, one good thing about Java is that you get order of operations, so you can do this, not this. And then at the very end, we do bw.close. Hey, okay, nice. Alright, hopefully this works. Please work, I beg. Come on, just do it. Make your dreams come true. Let's go. What? Aw, of course it doesn't work. Okay, is it too big or something? Okay, maybe it's too big. Let's try making everything long. I mean, that doesn't really make sense. 10 to the 9 should be plenty, but let's just make sure. I mean, I could binary search on M, but that's nasty. Is there no faster way? Hold up. Yeah, I think we might actually have to code up binary search to solve for M here. Okay, why don't we just code up binary search? Okay. Public int find M, and we'll take in the number. What are we gonna do? Or it's like a square, so we'll just say S. Okay. And we also need like our beginning and ending options. So start, int end, int s. Okay, so essentially int mid is going to be equal to start plus end over 2. And we're just going to make the recursive algorithm. So if mid times mid is greater than or equal or greater than s, then we're going to return find m start comma mid. Otherwise, we are going to, or start, yeah. But otherwise, that means that our, like, mid is valid, so then we want to return find m start comma, no, mid comma end comma s. Okay. And then at the very beginning, we want a base case, right? If start is e plus 1 is equal to n, then we want to return start. Okay. So here we'll just do find m. Well, what are we going to do? 0 comma some really big number. And, or let's make these long. And we want to find k plus x times x minus x over 2. I don't know why I did all the double nonsense. Like, this is guaranteed divisible by 2, but that should be fine. Okay. What? How is it an integer, though? What? How do you do longs, then? Oh, static, god dang it. Okay. That better? Bro, I'm not trying to make a what? Wait, let's see. Okay, whatever, that should be fine. Okay, that still gives you the same answer. Let's make sure it's a bit bigger. Nope, we can't do a bit bigger. Okay, let's do this. Okay, there must be an edge case, right? Like, basically, if you have, like, what? Hold up. Okay, where does this not work? If you're able to get it without, let's see. Yeah, one of m is, like, less than. Okay, so basically we had to do cases where we don't have to go up above, right? So let's see. So you got here, we got there, and if you just go like that the whole time, then and that works, then it should be fine. Okay, yeah. So basically, if we could just go like that, then our thing doesn't work. Is there any other case where it doesn't work? If that's the case, then what would the time be? It would just be you keep accelerating until you get there. Okay, let's do that. Okay, so first case is if like if t or x times like x plus 1 over 2 is greater than like k, right? We basically just return the ceiling of like what number, like t, ceiling of t times t plus 1 over 2, such that it gets there, right? Okay, well, let's make another function called find t. How about that? And basically, if it's mid times mid plus 1, then we return it. And we want ceiling though this time. So if it's greater than or equal to, and then we want to return end here. In this case, we just do bw.write find t 0 comma some big number comma k. What would it be? Or that'd be k. Okay. And we would break or continue actually. 3 is 3 right? So you could do 3 times 4 over 2 is 6. No, what? How's that right? What? Hold up. Oh, yeah, this is just that. And then, now it should work. Okay. What? Wait, hold up. So you can do 1 plus 2 plus 3 plus 4. Right? Oh, over 2. Okay, yeah, that would make sense. Alright. Oh, it's recursive. Oh my. Okay, that would. Bruh. Actual bruh moment. What the heck? Okay. Oh, okay, then this should be start. Okay. Okay, there we go. I think this is gonna work. Okay, hopefully. Whoops, this is how it should be. Okay, hold up. I think this is the right way to do it. Hold up. Please work, come on. I'm pretty sure I got it this time. Come on. Gotta work. There we go. Bruh, I'm so bad at debugging. God dang it. But we finally did it. There we go. Alright, thank you guys so much for watching. The race one is actually kind of hard, which is why I did a full video on it, like a full solo live solve for that one. So if you want a better explanation, go check that one out. But hope you guys enjoyed. Everything in Java, very epic. I still hate buffer rider to do. God dang it, what is that? But anyway, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what else you guys want down in the comments below. But other than that, thank you guys for watching again, and see you guys next time.